Good morning, students. So myself, Vijay Shankar from ECE Department, Chippewa Engineering College. Today, we are going to discuss about another topic in the oblique incidence, that is oblique incidence at a plane of a dielectric boundary. In previous classes, we discussed about the oblique incidence at a plane of conducting boundary. In that, there is two types of horizontal polarization and the vertical polarization. Horizontal polarization and vertical polarization. In both the horizontal and the vertical polarization, we derive the electric field E1 bar and the magnetic field H1 bar by taking the Snell's law of reflection, theta I is equal to theta R. And then we are substituting that it is EI is equal to minus ER or ER is equal to minus ER. Both the functions, we can bring that into the E1 bar and H1 bar in terms of incidence only, the EI and the theta I. Okay. In that, the velocity, the phase velocity also we find that phase velocity is V is equal to, or V1 is equal to V1x in terms of the V1x is equal to V1 by the sine theta I, because if you're having only the incident is there. If there is any transmission also, so what happens when if there is a transmission means definitely the boundary is in the dielectric boundary, oblique incidence in the dielectric boundary. So what is the velocity? The second velocity, the V2. See, in the previous classes, we derived the expression. See here, the V1x is equal to V1 by the sine theta I. V1x is equal to V1 by the sine theta I. In the x direction, both E and the H are in phase with respect to the time and space. There is a phase velocity in x direction in medium 1 is given by. There's the phase velocity in x direction, medium 1 is given by the V is equal to W by the beta. What is a beta 1? X is a beta 1 sine theta I. That sine theta I and the remaining function what we have here, the omega by the beta 1 is nothing but V1 by the sine theta I. Okay. You know the velocity V is equal to omega by the beta. Since the incidence is in the medium 1, that is the beta 1 and the V1 also. In x direction, so V1x is equal to beta 1x. The beta 1x is omega by, in the expression we get beta 1 into sine theta I. See the beta 1 x sine theta I is there in the x direction. So beta 1 sine theta I. According to the Snell's law of reflection, Snell's law of reflection, theta R and the theta I is both are the same. So then the function in the beta 1 x direction, the x term, x coefficient is beta 1 sine theta I, and the beta 1 sine theta R is a theta I on. So what is the omega beta 1 is equal to V1 by sine theta I. V1 by the sine theta I. So remember this expression. In terms of the wavelength also, the same thing, the wavelength the lambda is equal to 2 pi by the beta. Since it is in the medium 1, the beta 1 and the lambda 1, and the x term in the x direction, beta 1x, what is the beta 1x here? 2 pi by the beta 1 into sine theta. Beta 1 into sine theta. Because the beta 1, we are taking the incidence only, that is a medium 1. 2 pi by the beta. 2 pi by the beta is nothing but the lambda. So lambda 1 by the sine theta. Lambda 1 by the sine theta. Okay, my dear students. So using these equations, now let us take another topic. oblique incidence at a plane of dielectric boundary. Oblique incidence at a plane of dielectric boundary means the left hand side is a medium 1 and the right hand side we have the medium 2. In previous case, left hand side is the medium 1 and the right hand side is a medium 2 is conducting boundary. That now the medium 2 is also the dielectric boundary. Having the parameters is a different. Okay, let us, this is a boundary. In left hand side, it considers a medium 1. Medium 1 is a dielectric boundary. Dielectric and dielectric is only medium 2. With the parameters here, the epsilon 1, eta 1, beta 1, v1, the velocity, mu 1. Okay, all it is whatever the parameters we have, the permittivity, permeability, intrinsic impedance, the beta, the phase angle, alpha 1, attenuation constant, and the velocity v also. The same thing in the medium 2, the parameters are epsilon 2, eta 2, beta 2, v2, the velocity, and mu 2, permeability, and alpha 2 also. So both are dielectric only. Medium 1 is a dielectric and the medium 2 is also dielectric. Now we send a signal, not a beam, incident beam obliquely with a theta and angle. Okay. Theta I, the angle. Let us say here is the line, the theta I. The incidence beam, and there is a transmitted beam is also there with an angle of theta t and a reflected beam theta r. I'm not considering this which one is the EI or the HI function here. Depends upon the EI and the HI is a vertical polarization and the horizontal polarization. Means there is a medium 2 is also dielectric medium, means there is a transmission coefficient, or the transmission coefficient is not the 0. Got it, madam? Okay. In this previously, we derived the expressions as v, the velocity in the x direction, omega by the beta 1, x. The coefficient will get the beta 1 sine theta I. And that is equal to omega by the beta 1 is the v1 by the sine theta. v1 by the sine theta. Okay. Similarly, if there is a transmission, the theta t, v1x, suppose the velocity v2 is in the transmission, or the transmission in the medium 2. In the medium 2, it becomes of v1 or not the v1, the v2 of x is in the x direction, omega by the beta 2 of x, that is omega by beta 2 into sine theta t, because it is at the angle is the theta t, medium is the second medium, the beta 2, it becomes of v2 by the sine theta, v2 by sine theta. If both are equal, both are the equal, the velocities. Okay. You see here, the oblique incidence at a plane of conducting boundary, the previous sessions. Now consider the uniform plane wave is incidentally obliquely at the interface between the two dielectrics. The two dielectric mediums are assumed to be the lossless with the different constants such as mu1 epsilon 1 in the medium 1, while mu2 epsilon 2 for the medium 2. As the two mediums are having different constitute parameters at the boundary, thus there is as if discontinuity. Because of this interface, a part of incident wave is reflected and a part is transmitted. And there is an incident is there. fully it is not reflected because in the left hand, right hand side is a medium 2 is a dielectric. So a part of reflection and while the part of transmission is a plus. Okay, let us see here. This oblique incidence at a plane of dielectric boundary. The incident beam with an angle of theta I, there is a one part of angle ANR theta R, some part is reflected and some part is a transmitted. Okay, let us see. Is the incidence beam ANI bar. Okay, a transmitted, some part is a transmitted ANT bar, ANT bar with an angle of theta T, and here with an angle of theta I, and another one ANR bar with an angle of theta R. Okay, these are the three. Medium 1 is also dielectric and the medium 2 is also dielectric. So medium 1 is a dielectric and medium 2 is also dielectric with the parameters of mu3 epsilon 2 and mu1 epsilon 1. Okay, my dear students. This oblique incidence at a plane of dielectric boundary. To find it is a Snell's law of reflection and Snell's law of refraction. We already derived the expressions. Let us see here. Select the lines of OA and O dash, A dash, okay, whatever it is in this diagram. OA, it is from origin to the point A, that is the dotted lines we have. The dotted lines, what we are showing in this diagram. Already we know the ANI bar, ANT bar, and ANR bar. And draw all a perpendicular lines. Okay, perpendicular lines when we consider a O0 point, O dash, origin, a point O dash here. And there is a perpendicular line from the O dash to the A dash and the O to A and O dash to the B. All the dotted lines showing here. Let the lines OA and O dash, A dash and O dash to the B be the intersections of a plane of incidence with equiphase surfaces of incident, reflected and transmitted waves respectively. Okay, these are all, it is a 90 degrees. Here it is a 90 degrees for the transmission line, and for the reflection line there is a 90 degrees. Consider as this is a right angle triangle here and another right angle triangle here and another right angle triangle also. Okay, and when we take the perpendicular line of O to A and A dash to the O dash and O dash to the B. Okay, all we considered as the right angle triangles. Okay, the incident and the reflected waves travel in the medium 1 while transmitted wave is medium 2. Okay, in the left side there is incident beam, the ANI bar is there and ANR bar, both are in the medium 1. Only the transmission or the transmitted wave is in the medium 2. The velocities of the waves in medium 1 is same, say the V1, and medium 2 the velocity is also the same, so we say it is a V2. Got it? That velocity is the O dash sine theta I is equal to O dash sine theta R. I am taking the I is here, this is R. Okay, the velocities from the waves, the velocity for the waves in the medium 1 is same as the V1, is same, say the V1. Then the distances O A dash, let us see here. OA dash, this is a line, OA dash, and A O dash, these two, the lines are must be the same. Is a right angle triangle. If this is considered as a right angle and this is a right angle triangle, and these two, the lines O A dash and A O dash, these two lines are the same. Got it, my students? This is a reflected layer, and this is the same as ANI bar or ANI bar. Means its angles are the same, the theta I and the theta R. So this line will get as O dash sine theta I or the sine theta R. O dash is a hypotenuse, we can say here. And these are hypotenuse for these two, the right angle triangles. Let us take O dash. Means must be the same. Let us, I am taking here O dash sine theta R is equal to sine theta R is equal to, means here you can consider as angle sine theta R is equal to, we'll get as when we consider this angle is a theta I and this angle is a theta R, this right angle triangle, and O dash is equal, O dash sine theta R is equal to O dash sine theta I. Okay, my dear students. Means the first one is O A dash is equal to A O dash. A O dash, this is a right angle triangle with having the hypotenuse, we can say here, is opposite side. The opposite side is A O dash, and we consider as is a O dash is a sine theta R and the sine theta I. So both are equal. Then we can say O dash is the same, and the sine theta I and the sine theta R becomes theta R is equal to theta. Theta R is equal to theta. Means the angles is the same. That is in the medium one. Okay. Then see, my dear students, here the theta I R is equal to theta I. Then this is theta R and the theta I, we can call it as a Snell's law of reflection. Snell's law of reflection. Then see, it is also observed that the time taken by the incident wave to travel from A to O dash in medium 1, A to O dash in medium 1 is equal to the time taken by the transmitted wave to travel from O to B in medium 2. Thus we can write it as, see what they are saying here, the time taken for the incident wave travel in the medium 1 is the same as the time taken for the transmitted wave travel in the medium 2. Means ANI is equal to the ANT. The lines we can say here, see once again, come in this picture. So what they are saying, that the time taken for the incident beam, this is a line for the incident and this is also the line for the incidence only. The A to O dash is the same as O to B. The time taken for the incident from A to O dash is the same as the time taken for the transmitted in the medium to O to B is the same. Okay. Then the velocity is V2, V1 is equal to V2. What is a V1 and the V2? The sine theta I by what I already said, that is a V1 by the sine theta I by the sine theta T now. Okay. V1 by the sine theta I, that is nothing but the V1x, and V2 by the sine theta T is a V2x. So both are the equal. The time taken for the incident travel in the A to O dash and the time taken for the medium to O from O to B is the same. V1x is equal to V2x. That is nothing but the V1 by the sine theta I is equal to V2 by the sine theta T. Therefore, the sine theta T by sine theta I we can write as is equal to cross multiplying V2 by the V1. V2 by V1. Okay. So that is a V2 by the velocity V, where V1 is the velocity of the wave in the medium 1 and V2 is the velocity of the wave in the medium 2. That is the V2 by the V1 sine theta T by sine theta I. Simplifying the above equation, sine theta T by the sine theta I is equal to V2 by the V1. What is a V? V is equal to, we know, the W by the beta. When it is a V1, beta 1. When it is a V2, omega by the beta 2. So sine theta T by sine theta I is equal to V2 by the V1. Okay. So by using the V1 by the sine theta I, V2 by the sine theta I, we'll get the sine theta T by the sine theta I is equal to V2 by the V. What is a V2? Omega by the beta 2. And what is a V1? Omega by beta 1. So both having the numerator is the same. We'll get beta 1 by the beta 2. Beta 1 by the beta 2. Okay. But for any medium, the ratio of the speed of light in free space to the medium, to that in the medium is called the index of refraction. It is denoted by n. We know in physics also you'll get this formula, n is equal to C by V, where C is the velocity of light in free space and V is the velocity of light in a medium. Okay. Index of refraction, n is equal to C by V. The velocity of light in free space, 3 × 10⁸. No. Now, if I am considered as a medium 1, n1 is equal to C by the V1. Okay, the velocity of light in free space is the same. It's a n2 is equal to, if it is a medium 2, n2 is equal to C by V2. We know the V2 by V1. So V1 is equal to C by N1 and V2 is equal to C by N2. So V2 by the V1. What is the V2 by V1? V2 is equal to C by N2 by C by N1. That is equal to, both the numerator is the same, N1 by the N2. N1 by the N2 means it is also equal to N1 by N2, where N is the index of refraction. Got it, my dear students? So in the medium 1, N1 is equal to C by V1. In the medium 2, N2 is equal to C by V2. So sine theta T by the sine theta I is equal to N1 by N2. Sine theta by theta I is equal to V2 by V1. That is equal to beta 1 by beta 2. And that is equal to N1 by N2. This equation we call it as a Snell's law of refraction. Why? It is an index of refraction, where N is the index of refraction. The Snell's law of refraction. Snell's law of reflection is theta R is equal to theta I. Snell's law of refraction is sine theta T by sine theta I is equal to N1 by N2. Okay, my dear students. So now, what are the equations we got? V sine theta T. Once again, I will write these equations in order. Sine theta T by sine theta I is equal to V2 by V1. That is equal to, we got beta, in terms of beta is beta 1 by beta 2. In terms of the index of refraction, N1 by N2, means when this is sine theta T by sine theta is equal to N1 by N2, we can call it as a Snell's law of refraction. For a non-magnetic medium, mu1 is equal to mu2, that is equal to mu naught. Means the medium 1, the permeability is mu1, and in the medium 2, the permeability is mu2. In the non-magnetic medium, both we can call it, considered as a mu naught. Then you can derive the another expression is V1 is equal to the velocity. We know the velocity is equal to under 1 by the under root of mu epsilon. So the V1 is equal to 1 by, in the medium 1 we consider as a mu1 epsilon 1. When in the medium 2, the velocity V is equal to 1 by the mu2 epsilon 2. In the non-magnetic medium, consider these mu1 and the mu2 is equal to mu naught. That is equal to 1 by the under root of mu naught epsilon 1. That is equal to 1 by under root of mu naught epsilon 2. So we know V2 by V1 is equal to, what is the V2 by the V1? V2 by V1 is equal to, so 1 by under root of mu naught epsilon 2 whole divided by, and 1 by under root of mu naught epsilon 1. And you can simplify them. 1 by mu naught and 1 by mu naught both are the same, under root of epsilon 1 by the epsilon 1 by the epsilon. That is a sine theta T is equal to, again we got here under root of epsilon 1 by epsilon 2. Got it, my dear students? So sine theta T by sine theta I is equal to under root of epsilon 1 by the epsilon. Then and the intrinsic impedance. Now the another expression in terms of the intrinsic impedance theta is equal to, in the dielectric boundary, actually the formula is under root of j omega mu by sigma plus j omega epsilon. J omega mu by sigma plus j omega epsilon. Got it, my dear students? Because these two are dielectric, there is no any conductivity. Conductivity is 0 because of dielectric we are considered. Eta is equal to under root of j omega mu by j omega epsilon. Sigma is equal to 0. J omega get cancelled, under root of mu by epsilon. Eta is equal. When it is in the medium 1, eta 1 is equal to under root of mu1 by epsilon 1, and In the medium 2, eta 2 is equal to under root of epsilon 2 by the epsilon mu 2 by the epsilon 2, sorry. And in the non-magnetic medium, the mu naught and the mu 1 and the mu 2 is both are the mu naught only. Eta 2 is becomes under root of mu naught by epsilon 2. And eta 1 is equal to under root of mu naught by epsilon 1. So we know the under root of epsilon 1 by the epsilon 2 is will get as, or otherwise sine theta t by the sine theta I is equal to under root of mu naught epsilon 1 by the mu naught epsilon 2. You can write as eta 2 by the eta 1. Now you can represent that is a eta 2 by the eta 1 ratio between, what is the eta 2? Under root of mu naught by the epsilon 2 and under root of mu naught by epsilon 1. So these two are get cancelled. It becomes of eta 1 by the, not the eta, sorry, epsilon 1 by the epsilon 2 under root. So already we got this one. So intrinsic impedance eta 2 by the eta 1. Thus collectively we can write as sine theta t by sine theta I is equal to V2 by the V1, beta 1 by the beta 2, N1 by N2, and eta 2 by the eta 1, and under root of epsilon 1 by the epsilon 2. Got it, my dear students? In this, Snell's law of reflection is theta I is equal to theta R. Snell's law of refraction. Refraction means in terms of an index of refraction. That is a sine theta I theta t by sine theta I is equal to N1 by N2. N1 by N2. Now you can observe here the beta 1, N1, epsilon 1. The velocity and intrinsic impedance is a two terms, V2 by V1 and eta 2 by eta 1. Remaining all beta 1 by beta 2, N1 by N2, and under root of epsilon 1 by epsilon 2 only. Got it, my dear students? It's a very, very important equation. Collectively, totally, you can remember this one. Then you go for the total reflection. Total reflection. It is also dielectric and dielectric only, and there is a transmission here. Consider the medium 1 is denser as compared to the medium 2. That is, epsilon 1 is greater than the epsilon 2. In the medium 1, whatever the dielectric constant is there, the epsilon 1 is much more than that of the dielectric 2 in the medium, that is epsilon 2. Under this condition, the angle of transmission theta 2 becomes greater than the angle of incidence. When we consider the parameter epsilon 1 is greater than the epsilon 2, the angle of incidence theta I is the angle of incidence. Under this condition, the angle of transmission is much more greater than, or becomes greater than the angle of incidence, theta t. Okay, the theta t is greater than the theta I. What is the theta I? Is nothing but theta t is the 90 degrees, pi by 2. Okay, the angle of transmission theta t increases with an angle of incidence. When the theta t is equal to pi by 2, the transmitted wave will be aligned along the interface. This is a theta t, goes on increasing the value of theta t up to the 90 degrees. Whenever we can increase the change of the theta I up to the getting of theta t is equal to 90 degrees. The angle of transmission theta t increases with an angle of incidence theta I. where the theta t is equal to pi by 2, the transmitted wave will be aligned along the interface as shown in the figure. Okay, it becomes a 90 degrees. So as if the theta is increases further, then there will be no transmitted wave. If theta I is increases, still up to you have to increase to get it is a transmission is a pi by 2. Means if there is a transmission angle is a pi by 2 means there is no any transmitted wave, and the condition is named as a total reflection. Actually, when we consider the two mediums, in the medium 1 is a dielectric and the medium 2 is also dielectric. The incident beam with an angle of oblique incidence, the theta I, there some part is transmitted and some part is a reflection. And this transmission is also the changes to the 90 degrees with an change of the theta I. There is no any transmission here. If theta I is increases further, there will be no transmitted wave, and the condition is named as total reflection. The angle of incidence at which total reflection takes place. The angle of incidence. What is the definition of a total reflection here? The angle of incidence at which the total reflection takes place is called the critical angle, theta C. Okay, means the theta T is equal to pi by 2. When we'll get the theta T is equal to pi by 2, whenever you can change the theta I as increases up to the theta C, the angle of incidence at which total reflection takes place. Total reflection takes place is called angle of critical angle theta C. If the theta I is equal to theta C, that theta T is equal to pi by 2. We know the sine theta T by sine theta I is equal to, here the epsilon 1 is a one dielectric and epsilon 2 is another dielectric, under root of epsilon 1 by the epsilon 2, means sine theta T is pi by 2, and at the theta I is now the critical angle theta T C, epsilon 1 by the epsilon. What is the sine pi by 2 is a 1. 1 by sine theta C is equal to under root of epsilon 1 by the epsilon. Okay. Now, sine theta C, the critical angle, is under root of epsilon 2 by the epsilon. Okay. The total reflection, the angle of incidence at which the total reflection takes place is called the critical angle. Got it, my students? Theta C is equal to sine inverse epsilon 2 by the epsilon 1, or it is also called a sine inverse n2 by the n1. Beta is there, beta 1 by the beta 2. All the equal, because we already derived the expression sine theta T by the sine theta I is equal to V2 by the V1, beta 1 by the beta 2, n1 by n2, eta 2 by the eta 1, and under root of epsilon 1 by the epsilon. Okay. In this, theta C is equal to sine inverse under root of epsilon 2 by the epsilon, or sine inverse n2 by the n1. Total reflection. When the theta I is increases further, then there will be no transmitted wave, and the condition is named as total reflection. Still, it is goes to the increasing of theta pi by 2. You can increase the theta I. Okay, the theta I is changes as a theta C, critical angle. Then the theta T is changes to the 90 degrees. Still, it is increasing in this way. It increases the transmitted angle also up to the 90 degrees. At that, the angle of incidence at which the total reflection takes place, there is no any transmission. The total, it is a reflection, is called the critical angle. Got it, my students? Now we go for the vertical polarization and the horizontal polarization. The horizontal polarization in the dielectric between the uniform plane wave at a dielectric boundary. First is a horizontal polarization. The name of horizontal polarization is also called as a E-polarization, also called as a perpendicular polarization. Why it is a perpendicular polarization? The electric field E bar is perpendicular to the plane of incidence, or the electric field E bar is parallel to that of the surface, boundary surface. Okay. Then horizontal polarization also called as a perpendicular because of E is perpendicular to that of the incident beam or incident wave. And why it is a vertical polarization? Vertical polarization, which is parallel to that of the incident beam or the incident wave, and which is perpendicular to that of the boundary surface. Since it is a parallel, the E bar is parallel to the incident beam, and here the E bar is a perpendicular to the incident beam. We call it as a perpendicular polarization. And E bar is parallel to that of the incident beam, so we call it as a vertical polarization, is also called as parallel polarization, comparing with E bar. Got it, my dear students? So now we go for finding the equations of E1 bar and the H1 bar. In this, both the mediums are dielectric, means E1 bar is equal to E2 bar. E1 bar is equal to E2 bar. That is E1 in the medium 1, the combination of the two, EI and the ER, and E2, the ET bar. ET bar is equal to EI plus ER, because the incident and the reflected both are in the medium 1 only in the medium 2 there is a transmission. Similarly, for magnetic field, H1 bar is equal to H2 bar, that is HI bar plus HR bar is equal to HT bar. Got it, my dear students? You can find the what is the EI and the ER and the ET. Okay.